The world feels connected, everywhere, all the time. We send messages without thinking. We stream movies without waiting. We navigate cities without getting lost. It feels simple. It feels automatic. It feels like the air itself carries our thoughts. But above us, far beyond the clouds, far beyond the weather, far beyond the reach of airplanes, a hidden architecture orbits the Earth. A quiet network, a metal constellation, a system built on precision, a system built on timing, a system built on the speed of light. Most people never see it. Most people never think about it. But it is there, always, watching, listening, connecting. This is the story of how satellites connect the world. A story of distance, a story of latency, a story of engineering at the edge of the impossible, a story of two kingdoms in orbit, a story of Starlink, a story of why space internet is hard, and why it matters. Before the internet, before fiber optics, before Wi-Fi, before smartphones, humanity looked upward and dreamed of communication without borders. In 1957, the dream spoke. A tiny metal sphere, a simple radio transmitter, a repeating beep, 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 Sputnik. That sound echoed across the world. It was not just a signal, it was a message that Earth could speak to space, and space could speak back. That moment changed everything. It opened a new frontier, a frontier above the sky, a frontier where distance could be conquered by radio waves, a frontier where nations raced to place machines in orbit. Soon came weather satellites, watching storms from above, saving lives, predicting the future. Then came communication satellites, carrying television across oceans, connecting continents, shrinking the world. Then came navigation satellites, GPS, GLONASS, Galileo, Beidou, a global clockwork in the sky. And slowly, quietly, the sky became part of our infrastructure, part of our daily life, part of our civilization. To understand satellite internet, we must understand orbit. Orbit is not just altitude. Orbit is purpose. Orbit is physics. Orbit is identity. There are many orbits, but two dominate the world of communication. Geostationary orbit, the high throne, the old kingdom, the realm of stability, and low Earth orbit, the fast lane, the new kingdom, the realm of speed. These two orbits are separated not just by distance, but by philosophy, by design, by the way they shape the internet itself. 35,786 kilometers above the equator, there's a magical altitude. A satellite here moves at the same speed Earth rotates. One full orbit every 24 hours. Perfectly synchronized, perfectly aligned. From the ground, it looks still, frozen in the sky. A fixed point, a silent guardian. This is geostationary orbit, the high throne of communication. For decades, GEO satellites ruled global connectivity. They carried television signals across continents. They delivered weather data to meteorologists. They provided early internet to remote regions. They connected ships. They connected planes. They connected entire nations. One satellite could cover a third of the planet. 3 satellites could cover almost all of humanity. But this throne has a cost written in the laws of physics. Distance. A signal must travel up 35,000 kilometers, then down another 35,000, even at the speed of light. That journey takes time, a built-in delay, a pause you cannot remove, a latency you cannot escape. GEO is powerful, but GEO is slow. Now look much closer to Earth. Much closer, just 500 to 1,200 kilometers above us. This is low Earth orbit, the fast lane of the sky. Here, satellites move quickly, very quickly, about 27,000 kilometers per hour. One orbit every 90 minutes. They do not hover. They race. They streak across the sky like silent comets. But because they are close, signals travel faster, much faster. Latency drops from 600 milliseconds to around 20 to 40 milliseconds. A difference you can feel. A difference that changes everything. A difference that makes real-time communication possible. This is the realm of Starlink, OneWeb, Kuiper, Telesat Lightspeed, and the new space race. LEO is not just an orbit. LEO is a revolution. Latency is the villain of satellite communication. Not speed, not bandwidth. Latency. Latency is the time between asking a question and hearing the answer. On GEO, Latency is built into the system. A round trip of 70,000 kilometers. A minimum of half a second. Half a second may sound small, but in networking, it is huge. Click a link. Delay. Join a call. Delay. Play a game. Impossible. Latency breaks the illusion of instant communication. Latency makes the internet feel heavy. Latency makes the world feel far away. LEO changes this. By shrinking the distance, it shrinks the delay. A round trip of just 1,000 kilometers. A ping that feels almost like fiber. A connection that feels alive. This is why LEO matters. This is why the world is changing. This is why Starlink exists. Starlink is not a single satellite. It is a constellation, a swarm, a mesh, a moving network in the sky. Thousands of satellites, orbiting at 550 kilometers, working together, handing off connections, forming a global blanket of coverage. Each satellite is small, light, efficient, designed for mass production, designed for replacement, designed for scale. But how does Starlink actually work? On the ground sits a dish. But this dish is different. It is not a bowl. It is not a reflector. It is a phased array antenna, a flat panel, a sheet of electronics. It has no motors, no gears, no moving parts. It steers its beam electronically, instantly, silently, precisely. It tracks satellites as they race overhead, switching from one to the next, smoothly, seamlessly, without interruption. A dance of timing, a dance of physics, a dance of engineering. Each Starlink satellite carries solar panels, krypton ion thrusters, laser communication links, high-frequency antennas, navigation systems, collision avoidance AI. They talk to the ground. They talk to each other. They form a network in the sky. Laser links allow satellites to pass data across oceans, across continents, across the world, without touching Earth at all. Light in vacuum, faster than light in fiber. A new kind of backbone, a backbone in orbit. Even space internet needs Earth. Ground stations connect the constellation to the real internet. Fiber networks, data centers, cloud infrastructure. Your request goes up, across the sky, down to a ground station, then into the global web. A journey of milliseconds, a journey of light. Space internet sounds magical, but behind the magic is brutal engineering reality. Space is not friendly. Space is not easy. Space is not forgiving. Let's explore the challenges. In LEO, satellites never stop. They move at 27,000 kilometers per hour. They cross the sky in minutes. Your dish must switch between satellites. Perfectly, smoothly, instantly. A handoff every few minutes. A handoff without interruption. A handoff without delay. If the timing is wrong, your connection drops. Your stream freezes. Your call ends. Movement is the price of low latency. To cover the world, you need thousands of satellites. Not dozens. Not hundreds. Thousands. Launching them is expensive. Maintaining them is harder. Replacing them is constant. Space is getting crowded. Traffic control in orbit is now essential. Collision avoidance is now mandatory. The sky is becoming a highway. A highway with no lanes. A highway with no brakes. Space is not empty. Space is full of danger. Solar storms, radiation, charged particles, atmospheric drag. The sun can disrupt signals, damage electronics, knock satellites offline, or pull them out of orbit. Space weather is unpredictable. Space weather is powerful. Space weather is real. Radio frequencies are limited. Everyone wants bandwidth. Satellites must share the sky with 5G networks, military systems, aviation, weather radars, other constellations. Managing interference is a constant battle. A battle of physics, a battle of regulation, a battle of coordination. A GEO satellite costs hundreds of millions. A LEO constellation costs billions. Launches, ground stations, maintenance, regulations, manufacturing, upgrades. Space internet is not just engineering. It is economics. It is logistics. It is scale. The future is clear. A world where every village has internet. Every ship, every desert, every mountain, every island, every remote community. A world where satellites, fiber, and 5G work together. A hybrid planet, connected from the ocean floor to the edge of space. Starlink is only the beginning. OneWeb, Kuiper, Telesat, China's GW constellation. Europe's Iris superscript 2. The sky is becoming a digital frontier. A new layer of infrastructure. A new layer of civilization. Behind every satellite is a human story. A remote village connecting to online education. A ship in the Arctic receiving weather updates. A researcher in Antarctica joining a call. A family in a rural valley streaming a movie. A doctor in a remote clinic accessing medical data. A student discovering the world for the first time. Space Internet is not about satellites. Is about people. Is about opportunity. Is about connection. Look up at the night sky. Somewhere above you, a satellite is passing overhead, carrying someone's message, someone's voice, someone's hope. The world is connected not by magic, but by engineering, by physics, by courage. This is how satellites connect the world. This is the invisible architecture above us. This is the future, orbiting quietly, in the dark. Thanks for watching, and I'll see you in the next chapter of this digital adventure.